Right, class. So, good morning. Um, I left out at this point on Saturday and I told you regarding triglycerides, which is our next section of lipids. So, I have already discussed related to their storage form in your body, and I have told you that basically they are there as an energy reserve. Primarily, let me clarify over here one thing that whenever your body needs energy, it is not going directly targeting fats or lipids. They are initially targeting the carbohydrates, and you know better that carbohydrates energy reserve in our body is it is glycogen. Okay, so from the primary sources are carbohydrate, protein, etc. So when the matter of lipid comes, I told you on the last Saturday that lipids are an energy reserve of emergency conditions. So when the body starts breaking down lipids, it's not a good signal, right? So and they are being stored in adipose tissues, and they are actually meant for preventing you from shock and cold, right? So I definitely have to involve the reactions, because I want this subject to be applied in your daily life, and I have already associated this subject with your daily life. That is what you are consuming, that depends upon your health conditions and the effect of those consumed biomolecules on your health, right? So in the same regards, as I have shown you some of the examples earlier also, so I'm going to describe about hydrogenation, oxidation, and the saponification, which is a base catalyzed reaction. What is a base catalyzed hydrolysis? Because you have involved a alkali over here, which is dissociated into a positive and a negative charge molecules. Okay, so let's jump to the next one. So this diagram, dear students, is going to tell you more things related to the movement of fats inside your body. What exactly I would like to tell you, that when your fat is entering inside the body, I told you that fats are not solubilized in polar solvents, but your internal environment is totally aqueous in nature. So when you consume fat, there are certain requirements of those I can say the movement needs to be in certain aqueous vehicle. The vehicle must be, I mean, what are transporters? Transporters are the things, I mean, the vehicles which carry from one location to another location. So similarly, your body, when it digestion system is over, what happened is that the movement at different locations start. So here it is written that the when triglycerides is being consumed, I mean only lipids is being consumed, the monoglycerides and fatty acids which are being released after the hydrolysis of triglycerides, they are absorbed by intestines and then transported as chylomicrons in lymph system to the blood. So mainly to carry these particular components, you have certain vehicles. So I have written over here, I mean, if you even know this VLDL, LDL, and HDL. VLDL is very low density lipoproteins, LDL is low density lipoproteins, and HDL is high density lipoproteins. So if you correlate, how will you remember the things? Just understand that LDL is opposite to HDL. LDL carries or transfers the cholesterol. I'll discuss cholesterol later on. Transfers the cholesterol to tissues from liver, right? So liver से tissue में ले जाता है, and then HDL is vice versa. It carries from tissues to liver, right? So VLDL carries the triglycerides from liver to tissues. So VLDL is totally different, HDL is totally different, LDL is totally different. So when HDL is being talked about, it carries from tissues to liver. It is a good cholesterol because it gets rid of your cholesterol from the tissues and it carries it to the liver. But HDL को हमें ज़्यादा heavily loaded नहीं करना, because if it carries more of the cholesterol to liver, it may becomes, your liver may becomes fatty liver. Okay, these are just simple understanding of fat metabolism. Fine. So the first reaction I would be liking over here to tell you is hydrogenation. I'm not going to discuss this too much in detail. Hydrogenation is a simple reaction where the liquid fat is converted to a solid fat. You have already seen this earlier. I mean, when you do the hydrogenation of alkenes, what happened is that hydrogenation is the addition of hydrogen, right? So the alkenes is having double bond. When you add hydrogen, it will be converted to a single bond. So that is conversion of alkenes to alkanes. Similarly, when you are adding hydrogenation, or when you are carrying out the process of hydrogenation with liquid fat or oil, it produces a hardened fat. So that is a very common kind of reaction for producing the butter, the dalda, ghee, etc. So it is written that vegetable oils are hydrogenated to produce such solid products which are used to making the baked products. Why in bakery? Because इसकी वजह से चीज़ hardened रहती है, means in bakery the things get smooth and hardened. That is why they are using these hardened fats. Animal fats such as butter, which are naturally saturated, can also be used, but butter have some undesirable health reason. That is why people are not using them. Okay. So hydrogenation is an easy one. This is hydrogenation. You can see the alkene is being attacked by hydrogen in presence of a catalyst, which is platinum. Now you can see it is conversion of unsaturated to saturated one. This is basically a hydrogenation reaction, right? When I am talking about the triglyceride, previously I have shown you alkenes to alkanes. Here it is a triglyceride. So these three locations, as I have already earlier discussed with you. So hydrogen is being added, right, with platinum as a catalyst. So resulting in the product like this. You can see all the double bond has been broken down, right? So this is liquid, this is a solid fat. So this is due to the resultant of the hydrogenation, right? Okay, so when I'm talking about hydrogenation, there the product can be found because of the resultant of two various kind of hydrogenation. I mean, partial hydrogenation and complete hydrogenation. So I'll be describing this in my next uploading presentation. Thank you.